All right, so I just wanted to go through a couple of examples. And although these are two examples, they can be applied to a majority of your homework. So for this first example, it says find the frequency period, angular velocity, number of cycles seen below, and how many cycles will be completed in 1 second for the waveform below. So to start, what I started with is trying to find the period first. I find that finding the period is the easiest thing to do in this situation. And so basically, how you find the period is you start looking at points within the waveform that it starts to repeat itself. So, I mean, you can start anywhere on this waveform, but traditionally it'd be easier if you just start from the very beginning, from the left and work your way to the right. So right here, you can see this waveform this triangular waveform starts to go up, comes back down to -5 volts, and it goes back up again. So therefore, it starts to repeat itself right here. And so basically what that means is that's your period. So your period for this waveform is 1 millisecond, as I indicated right here. All right, so from there, you can find your frequency. Because frequency is related to your period. All you have to do is just plug and chug into the basic formula right here. So frequency equals 1/period. And so you get 1/1 millisecond, which equals 1,000 hertz. Or you can say it equals 1 kilohertz. All right, so the next question asks you, how many cycles do you see in this waveform right here? In this little snapshot right here, how many cycles do you see? And so if we go and we count them, we see, okay, this right here, this is 1 cycle. All right, so then it repeats itself. This is 2 cycles. And then this is 3 cycles. So therefore, within this snapshot, this 3 millisecond snapshot, you have 3 cycles. All right, and so the last question asks you how many cycles will the waveform complete in 1 second. So if you saw the full 1 second, you could literally go through and count each cycle, just like we did right here. We just keep going until we get to 1 second, but that's going to be kind of tedious for this high frequency. So, I mean, if you think about it, I mean, you really already kind of know the answer, because frequency is equal to the number of cycles per second. All right, so number of cycles per second is your frequency. So in other words, however many cycles that's completed in 1 second is your frequency. And frequency is measured in hertz. So before, we calculated frequency to be 1,000 hertz. So therefore, how many cycles are going to be completed in 1 second? 1,000. So therefore, the number of cycles in 1 second will be 1,000. Velocity for this one is pretty straightforward as well, which is denoted as omega equals 2 pi f. All right, so all we do is just plug and chug 2 pi, and then our frequency is 1000 hertz. And so therefore that equals what? 2 pi 1000. Which is equal to 6 to 8 3 right per second. So 6,283 radians per second. All right, so that's your angular velocity for example 1. Let's go into example 2. So example 2 says find the frequency, period, angular velocity, number of cycles seen below, and how many cycles will be completed in 1 second. Then write the sinusoidal expression and determine the RMS voltage. Excuse me. So just like we did before. So, but before we go any further, let's analyze this waveform. It looks a little different, but we can see that we can see that this waveform we can go all the way up to 1 second. So therefore, if we wanted to count how many cycles, we could on this one because the frequency is small enough so that we can just count them. So therefore, if we wanted to count how many cycles that's in this waveform right here, and within 1 second, we can say, okay, this is 1. This is 2 cycles. This is 3 cycles. So therefore, ask yourself. So if we complete 3 complete cycles in 1 second, what's the frequency? Well, 3 cycles per second is equal to 3 hertz. So your frequency is 3 hertz, which in other words, 3 cycles per second. All right, so you could use your frequency that you just found, 3 hertz, and plug it back into the period equation. All right, I'm gonna write it down here. So period is equal to 1 over F. And so therefore, you get 1 over 3 hertz, which equals to, it's really 333.33 milliseconds. Or you can do kind of what I try to do is I try to put your little cursor right here, so that way you can kind of see where it crosses the 0 axis. So right here, saying this cursor 1 is crossing at 333.05 milliseconds. Not quite, but close enough. So your period is equal to 333.33 or 0.01, depending on which one you use. But overall, when you come over here and calculate your frequency, it's going to equal close enough to 3. And so number of cycles that you see here, which is 3. So 3 cycles. 1, 2, 3. All right, and so the number of cycles per second, just like we did before, we know we have 3 hertz, so therefore it's three cycles per second. And so now this one asks you to write it in the sinusoidal expression and determine the RMS voltage, which is pretty straightforward as long as you know the format it needs to be in. So you have right here is your amplitude, and right here is your angular velocity, and this is just time. So the T usually just stays here unless there's a particular time that you're asked to determine the voltage at. But T usually is just represented as T. All right, so the amplitude. So how do we find the amplitude? Well, the amplitude is from 0 to the maximum point that this waveform goes up to, which this one just so happens to be 20. All right. If they actually for the peak to peak means from this peak to this peak. So peak to peak will be 40 volts. But this one just wants the amplitude, which is sometimes referred to as the peak voltage, which is equal to 20 volts. So that's the amplitude. All right, so right here now you need to figure out the angular velocity. And so we haven't done that. So the angular velocity equals to 2 pi f. Just 2 pi times f, our frequency, which is 3 hertz. And that equals 18.85 per second. And so from here, we have everything we need. All we got to do is just plug and chug. So you got your amplitude 20. You have your angular velocity, which is 18.85. And so this is volts. All right, so if you want to find the RMS voltage, all you do is just divide by the square root 3. Not square root 3. Excuse me. You divide by the square root 2. And so once you do that, you'll get 14.14 volts. So same thing if this was current, the RMS current, RMS will equal I divided by square root 2. That's when you divide the amplitude of the current or the voltage by the square root 2, you're converting that sine wave into a RMS voltage or current. All right, so that's it for these two examples. Like I said, I mean, these two examples alone will help you out through majority of your homework that you have been assigned for this week. But still, if you have any questions, feel free to reach out to me. All right, thank you.